under the glass of a frozen sea. A secret stirs where no eyes can see, like whispers trapped in a crystal tomb. Europa hums its ancient tune. I think of our stuck buried deep, a lake that dreams but cannot sleep. What waits below? What breeze? What hides in the heart of ice, where time collides? Signals flash like ghostly flares, answers tangled in cold threads. Beneath the ice of Europa, life seems soft like a distant nova. Are they monsters or are they kin? Do they fear us or let us in? Beneath the ice of Europa, life seems soft like a distant nova. Are they monsters or are they kin? Do they fear us or let us in? Wheels pierce down, machines hum low, to touch the past, to learn to know. A glimmer, a movement, a fleeting trace, a trembling hand, a foreign I think of explorers long ago who chipped at secrets locked in snow. They found life where none should be, a mirror of us beneath the sea.
Oh, you gotta love that song. Hey guys, welcome. And here we are. Can't believe we're back. It's just one day so far of clarity, but it's the beginning of more. I mean, not a single day before this in July was clear. Welcome to the monsoon, right? Hey, here we go. Hi, I'm Mark D'Antonio with you again for Skytour live stream. We are going to have a wonderful night. Yes, that's Venus sitting there near the western horizon. I figured, why not have something we can look at while the sky gets darker? And that's what we got right there. That looks pretty. Now, that's the sharpened version. If I take it off, you'll see it's actually not that much different. This is the live version of it right there. And it's really looking pretty cool. That's actually one of the better views. It's a very nice night out there. The wind is maybe 1 to 2 miles an hour. Can you believe it? 1 to 2 miles an hour. That's perfect. That's perfect for us. And I am wearing a sweatshirt, and it's summer here. It was 90 here today. Extremely oppressively hot outside, and we're under a very severe thunderstorm watch. So if we just go blank, we lost power. Okay, so we got storms outside around us, but right now we got nothing. So I'm squeezing this in if I can get it in. So how are you guys? How's it going? Fill me in, everybody. Tell me how it's going. What have you done since we last talked? I'm really happy to see you all here. I can't start the stream without saying that JSCO was the first one here. Okay, just saying. All right, good to see you. Kathy Messick was second, but a close second. And then we have Richard Spencer who's come in. Daisy and Zoe, nice to see you guys. And you're the early birds, actually. And let's see who else. There's somebody else here that was here. Yeah, Immortal Sergeant. There you are. Nice to see you, man. And we have is that PBC Bucket? How you doing? Howdy to you as well. Good to see you, man. And so we are gonna start off, like I said, with Venus. Why not? Because it's there. And we will be checking it out. Let me move it more into the middle here. And to see where it is in the sky is kind of important, because I need you to see what we're looking at here. First of all, for those who I know you've joined us before, you know who we are, what we do. I'm just going to do one thing here. I'm going to move myself down and take this little piece right here, all right, and pull it down out of the view so you can see our telescope there. The other telescope is right there. You can see it. That's it, right there. Okay, which is right there. Let me see where I'm going here. Okay, over here. So there it is, right there. Okay, you can see my cursor, and it's here. And our third telescope, being donated by Bob McGuire, mathematician, PhD mathematician, and guy who, like me, saw a USO on a U.S. submarine years ago, decades ago, has donated a big telescope to us, which we're working out getting the transport ready. He sent me the list of everything that's coming, and I gotta tell you, it is unbelievable. So we're going to be exploring the sky differently when we get that telescope, and you'll see what I mean when it comes in. Now, here we have, as I said, we have Venus right here. Now, you'll notice that it doesn't look round or whatever. It has this, basically looks like a first quarter moon, doesn't it? Out of a very, very, really bad telescope. And that's because planets that are closer to the sun than Earth show phases. Mercury has phases. Venus has phases. The moon, because it's going around the Earth, we can see it lit from different perspectives, and that's what we're seeing with Venus as it goes around the sun. Just a different path. And so Venus, they used to call it our sister planet, and unfortunately, for a sister planet, it was actually nothing like a sister. It was more like a torturer, more like a satanic planet, if you will, to the Earth. Absolutely crazy. So it wasn't one of these things where we would say that this was a very good planet to consider as one that would be well, a sister to us. Not at all. So temperatures on the surface are actually a relatively cool 900 degrees Fahrenheit. All right, 900 degrees Fahrenheit. Can you believe that? And then temperatures in the upper atmosphere of Venus are relatively cool, and that's like 70 degrees, 80 degrees. But the clouds are made of sulfuric acid. And so you'd get kind of disassembled atom by atom in the upper atmosphere. Survival would not be a possibility on Venus. Now, one thing that's true is that Venus is, if we have every star has a habitable zone, the not too hot, not too cold, Goldilocks zone as we call it. And Venus is near the inside edge of our habitable zone, and Mars is just near the outside edge. So Venus and Mars kind of bracket our habitable zone a little bit, and the Earth is sort of part way into our habitable zone. So Earth could actually survive being a little cooler than it is, or a slight bit hotter, but and still be able to foster life. So it's pretty cool. Hello, Star Panda, C&D Boy. Nice to see you here. And Marianne Robb is here. Hey, how you doing? And Kelly and David are here. Where are they? Oh, there they are. Oh, look at that. Kelly Clark. That's Kelly and David from Adelaide watching us. I met them at Contact in the Desert. Amazing people, you know. So nice to see you guys here. Thank you for joining us. It is our return to streaming after not being able to stream for literally all of July. Last time we could stream was the end of June, and it was only a short one because we only looked at a couple things. That said, we have Venus here on the horizon. Let's actually bring up our system here so you can see we're literally Venus right here. It's literally really low to the horizon. It's only 12 degrees above the horizon, but we still get an image like that, okay, from it. So the more air you're looking through along the curve of the Earth, the shakier things get. That's why we have a little red fringe on it. There's actually, that's not glowing lava or anything like that. That's actually just a camera artifact. And you'll notice that there's blue here. So we're getting what's called aberration. And that's because of the amount of air we're looking through. It tends to disrupt the imagery and the images along sharp edges. And that's like the edge of the planet. So as it's getting darker, however, we will be able to move to other things. And now you can see that as we zoom out here, all right, we're saying goodbye to Virgo and Galaxy season. And we're going to be saying hello to, as we move more toward the south here, we're going to be saying hello to the summer Milky Way. Look at that. It's right there. Oh, it's beautiful. And there's so much to see here. And I think we're going to start with what's called the Crab Globular Cluster. And we're going to go to it. Let's try, because I don't know if the telescope, the wide field system, is suited, perfectly suited to this, I'm going to come over here to the wide field system. We are running both. And I am going to bring up the same view. I'm going to send this to this cluster, and let's see if we can see it with this telescope. So I've told the telescope to get going. All right, and as you can see, it is moving. All right, that's right there, moving. Okay, and it's gonna be looking. See, there's Antares right there. You can see Antares, so it should be able to see it, I would think. We're gonna find out in just a minute. It might be too close to the wall. Yeah. Yeah, it looks like it's gonna be too close to the wall to see, unfortunately. Well, let's see what it thinks it sees anyway. I don't imagine we're gonna see it. Let me do our quick pick. This telescope in this building is a temporary placement for this telescope. This is okay. Unfortunately, because let me set the gain too. This is because of the fact that we are looking at another system. We didn't expect to put this system in this building, and we had to. Next time I'm out there, I'm going to raise it up higher in the sky. Let me actually try something different. Let's go to Antares. Make sure we can see that. I'm also hoping that we're not going to get any clouds. Yeah, okay. Antares is a little bit further down. Yeah, we're not going to see it. Okay, so let's try looking at the Gumball Globular Cluster. Let's go way up. That we'll see. And this is, again, the wide field system. Okay, I don't see an image at all. That's not right. I tested the cameras. They worked. Let me close the camera and reopen the camera. Yeah, okay. So let me bring us down here. Oh, let me get rid of this first. And then let's go back up. No, that, okay, there's stars. Okay, there we are. All right, so that's good. So what I'll do here is I'm going to see if we can get our position and confirm it. 15, huh? Let's see if that works. Could not sync. Okay, so I'm going to move the scope to the west. Okay. You're doing this for the first time with me as well, so. Okay, now let's try this. Alright, that one should work. Let's try that one. Opposite side of the meridian. Let's confirm. Is that true? Nope, shouldn't be true. All right, so that should not be true. All right, let's do this. I'm going to try one more thing. I am going to go to something which I know will require that. Actually, let me. Patience. The rose cluster. That's a good one. We'll try that one. That'll get us to where we want to go. Let's hope. All right, we should see our system move over there. Okay, let's do this. And do this one time. Gotta disconnect and reconnect, see what's going on here. Alright, connected. Now it says we're there. But we come here and it won't be there. So I have to try to figure out where we are. Alright. Let's see if it'll work. Shouldn't have to do what it's telling me to do. I'll say yes anyway and just see what's going to happen here. There it is. There it is, okay. Alright, so it lied. It said it was going to have to flip the telescope over the other way, and it did not. Didn't have to. So that was all a lie. It lies. It always lies. Okay. So let's do this. Let's take... This is our low light mode, by the way. So let's move this over. All right, so this cluster is now in there. I don't ever take no for an answer. I figure things out. Okay, so this is beautiful. This is really looking pretty. All right, so let's get this. Actually, I can do so much easier. We can just tell it to do this and figure out what it's looking at. It'll note that, and then I'll tell it to take this globular cluster, which is Measure 5, and center it into view. Okay, there we go. And there we are. And so let's start the evening by, first of all, plugging in our guider. It's not plugged in yet. Now it is. And we're going to do 1 second exposure. Let's do that. Oh, we got plenty of stars. Let's bring this back to make it a little more. This is for our visual thing. The camera sees more stars anyway. And we're going to tell it to grab a number of stars here. And it's got that one. So we're going to tell it to start guiding on that. Nice peak right there. Just even the exposure is a little too much because you want that to be all just rounded, but that should work. Now let's go take a deep exposure. Let's take an exposure. This is our wide field system, by the way, the wide field. So let's take at, let's say, 150 gain. We're going to take an exposure of, let's say, 20 seconds. 20 seconds. Okay. And then we'll come out of our low light mode and jump into our live stack mode. All right. So there we are. Let's get rid of that. All right. So our first, this is again wide field. Our first view is coming here. And there it is. Now that looks crazy, I know, but that's because we haven't done any corrections. So I'm going to do a correction. You're going to start to see these curves align with the next exposure. A satellite went through over there. We'll do a color correction. Okay. It's still a little bright sky yet, but that's okay. And let's do this. We're going to zoom this and move up to the curves so we have more control. You can see better now. You can see how we have to ride that dark level up the white average curve like this. And look at that. That's beautiful. And then we'll just pull this down. Oh, yeah. And then that'll just neaten right up. Look at that. Wow, what a beautiful cluster. I'll pull this down even more. All right, and then it will look at that. That's gorgeous. Let's see what we got running for enhancement. I don't have anything there. We got color noise reduction, which is good. If I had an unsharp mask, it's going to get almost too sharpy sharp. Yeah. We'll run without it for a moment. This is, hi Isabella, nice to see you. And Corticopia, that's Courtney. Hi Courtney. This is the globular cluster known as Measure 5, also known as the Rose cluster. It is here. We are over here in this constellation of Serpens, right here. And you can see Serpens, the serpent. And we're looking at it here. We have yet to go over to the Milky Way objects over here. We're gonna get there. I'm gonna try looking at this again because I wanted to see Measure 4, and when we look here, it usually we can see it, but the telescope here is kind of close to that wall toward the south, and I had no choice for that. But the best thing I can do is raise that telescope up, and that's what the next trip will do, is to raise that telescope up, if we're not installing the big 14-inch that we were donated by Bob McGuire, scientist Bob McGuire. Okay. All right, that said, that's beautiful, and I'm going to save this. That's 8 exposures. We'll save that, and we'll get stored. All right, and that's going to be stored as a FITS file, which is our astronomical file format. And then I'll save it as a PNG file, so you can get just this image exactly as you see it. All right. And so now that we are all coordinated and set up, what I'm going to do is I am going to go back to our low light mode and try to head down to Antares. And it looked like the wall was blocking it, and it may have blocked it, but I want to try anyway. I want to come down to this star and see if we can see it. And it's going to be questionable, but we're going to see. All right, there we go. You can see it's moving. It's going to turn right around and go in there. Yeah, and it's there, but you're seeing a glow from the wall. And you can see, of course, the wall right there. So we definitely have to raise the telescope higher, but we are going to be installing another telescope. There goes the satellite, Starlink. Okay, so that's not working, but what is working is if we come over here and we come to, let's say, the Lagoon Nebula. We're going to check out a lot of these other things too, don't worry. So we're going to go to the Lagoon Nebula. I believe that the lagoon is visible. As you can see, the telescope goes way up. And the lagoon will... Where's the telescope going? Well, it's got to turn around. Okay. It has to spin around and look at it from the other side because it's not at the meridian yet. The center line, so it has to flip it to the other side, which is what it's doing. Okay. So we'll just wait for a sec for it to do that. And see where it ends up. It may find it right away, or I may have to, tell it where it is, but it's going to be pretty high in the sky for us here. That's about right. Oh, I still see we got a little bit. There it is. But we do have, let's do this. We do have a little impingement on the building here. So I'm going to be definitely working on getting that raised up. This sounds like Charlie Brown Christmas in the background. Okay. Yeah, that kind of looks like it. Let me do an exposure of it to see. And I'm not guiding on it right now. Not that right now. It was guiding on the other, on Measure 5. Let's make sure that we're looking at what we expect. Well, actually, we can tell. Lagoon Nebula. And it needs to be higher in the sky, so it's let's take a look here. It is, I think it's as high as it's going to get right now with this. So until we raise it up, yeah, it's almost as high as you can get. It's going to get a little higher, so we might actually be okay. once we raise the telescope, it'll be fine. Okay, so now let's do a nice exposure here, and that'll be a 25-second exposure. And let's grab a guide star, and from where it's sitting, not sure it'll be able to get a guide star. Yeah, it's actually seeing the side of the building. So a guide star is not going to work there for this particular object right now, but we'll try it. We'll give it a shot. It's off and running. In a wide field, it doesn't necessarily need that. But what I'll do is take that into account and work on getting the other telescope trained onto that as well. Yeah, there you go. Okay, so let's I didn't stack it, so I'm gonna do that again. Let's wait and see. Yeah, the red is from the red light of the telescope system. It's actually visible. Let's see if we can. It's because it's on the wall. Let's see if we color correct it. It might help us. Yeah, a little bit. Waiting for it to get fully dark. Let's do this. Yeah, it's beautiful. But I think that we might be able to do better. To do better, we're going to need to go to the different telescope that's higher. And that one is going to really make a nice impression on you for sure. So let's do that. This part here, this is the building right here that's in the way, but you can see the beautiful nebula there. But we can do better than this, and we're going to. And I'm just going to gonna make sure that we can. Let me bring you over to here. All right, and we're going to look at this other view of it. Okay, let's let me do fit the height. All right, let's do that again. We're getting a data drop out here, so give me a moment. Yeah, it's just Isabella, Mark's army of telescope robots. Yeah, sometimes they listen and sometimes they don't. Okay, so there we are. Now I'm going to make sure we can get our we got that already. You know, 1 second. I'm gonna restart this session here because it looks like it's a little slow, and I don't like that. So let's try it again. Get rid of her. Okay, let's go over here. All right. So are we back? Okay. So I'm gonna come over here now. Take the narrow field and grab the narrow field. So momentarily you're gonna see some craziness, and then I'm gonna do that, and then we're back. Okay. All right. So now that we're here, I am gonna change our time from a fraction of a second to 1 second, and that will change this drastically. There we are, and there is a nebula, and we can just bring it in, and this will be the center part of the nebula. This is beautiful. Okay, look at that. This nebula tells such a story, you have no idea. Well, you will have an idea when I'm done, because I'm going to tell you all about it. I'm sorry too, I'm also nervous about the storms outside, and so that's another reason why I'm a little flighty tonight. It figures the first night we get clear skies out there, we have major storms here. We had tornado watch as well the other day. Not right now. Okay, this beautiful nebula tells such a story because up there, in fact, exactly while we're in this mode here, I'll tell you, right here, that star right there, that is one of the hottest stars in the universe right there. That's an O-type star. That star is one of the hottest and bluest stars in the universe, and what it's doing is it's throwing off so much ultraviolet radiation that this entire nebula here is getting ionized. The atoms of hydrogen gas are getting ionized, meaning their electrons are being blown off the atoms by the electrons gaining so much energy they leave their orbits, their orbitals around the hydrogen atom, leave the atom for a period of time. Then they bounce around out there and then come back in, and when they lose some energy, and as they come back in, they give off the energy in the form of light, and that light happens to be red, which is what we see here. And it's this right here, that hourglass figure that you see there, that is characteristic of the lagoon, and that's the part that's the hottest and most extremely inhospitable place you ever want to go. Please don't ever go there. Right, if you got a chance. So that's pretty cool. Aurelio Maraca's with us, the curator of the Danbury Library UFO conference. Nice to see you here, my friend. Thank you for coming. Sam S is with us, and Kelly Clark says, Marianne, it was so fun to do, lots of laughs. Oh, you guys are having fun. And we have Donald with us, and I told Ronald specifically to come see us, and he didn't come. So I don't think he got the message. He better come up and get off the stick. Yeah, Donald Kunzer, good to see you. Aeolian, nice to see you. Jerry Klein, good to see you as well. Holly, I am Holly, nice to see you. I am Groot. And David John Clark, nice to see you. Oh, I put it up on the big screen, David. Yeah, that's a great idea. That's what people do. They'll put it up on the big screen and watch. And for this nebula, you'll be happy you did, because we're about to take an exposure here, and we're at 250. I'm going to drop it at 200 to get just a little less noise. And what this will do is it'll lessen the amount of noise that we see. But I'm going to grab us a guide star, because we will certainly have them for this. And I'll probably just want to connect everything first, so I'll do that. Right, and then we'll take an exposure at 1 second. And there's we go. I'm going to get rid of these target markers. We don't need them. All right, and let's see. Okay, and then we'll grab a star. And there we go. And let's say we're going to guide on that square star right there. There's our peak. That's a great peak. So now we're guiding, and now what we can do is take an exposure. What I'm going to do before I do that is set the exposure, and we're going to do a 25-second exposure here, and we already set it off, and we're in low light mode, so you can kind of see what's going on. Oh, look, we got moths flying around in there. And now we'll come out of low light mode, and you'll notice down at the lower right, down here, you can see right behind the Asterian logo, one of our foundation sponsors. We're building an image and we have 2 seconds to go, and I'm gonna hit the stack button as well, and we'll see the next one that comes in. And this is, you're gonna see what I mean by those red colors, because the telescope picks up some of the color when it's raw imagery, when you're looking at it with a camera like this, but the letting the light fall on the sensor is what will make it really stand out. And now you'll see it. All right, so here it comes right now. Okay, this is the Lagoon Nebula. Check that out. Now I'm gonna color correct it a little bit, and that's what that's gonna do. And then we're going to, now we're looking at the center of it, and what I'm gonna do is I'm then gonna do a processing correction to help us see some of the things in there. Now I'll go into our zoom feature to allow me more access to the curves here. You'll notice it goes up to a peak and then tapers off slowly. All right, and as we go, that's going to change more into a more of a bell curve as we take more exposures. And this here is this curve indicator. We grab it and we slide it. You watch what it does to the image. Ready? So watch this. Now you'll see that yellow line. We're pulling in more of that curve. We go too far, and it's just too much. So we want to go just enough in so we can start to see some detail. Now, what we've done here is we set it to the height. This is a square sensor, so this is the actual image that we see. All right, it's beautiful. This is the Lagoon Nebula. Now, in this particular case, you'll notice there's dark stuff in here. This dark stuff, we're going to zoom in because we've got 4 shots captured here, 4 very perfectly guided shots. And what we're going to do is look at these in a minute. And Southern, how you doing? Southern Merbabe. Okay, nice to see you, man. And Amanda's with us, Amanda Ferguson. Great to see you. Elise Tildy Yvonne is with us. Nice to see you as well. Eliza, sorry. And so now as we bring in more of these, you'll see the red areas here. Now that hourglass I showed you with this O star, that's it right there. There's the O star, right? And if we come up again, I'll show you. There is that little hourglass figure right there. See it? Right there. And right there is the O star. That's the hottest and bluest, one of the hottest and bluest stars in the universe. And it's responsible for lighting up this nebula by, ionizing the hydrogen gas and causing it to then, turn around and when the electrons come back in, they give off this red light. That's exactly what they do. And it looks just, it's something else. I'm just going to adjust the camera here a little bit. All right. So now over here we have 7 shots, and this is the narrow field system. You'll notice it says narrow up there in the upper right. And this other image here, which we're still pulling in, that's the wide field shot. So you can see we see a lot more. We'll be able to use that wide field shortly when we look at objects higher in the sky. Like I said, it's not a lost cause. Let's zoom in on this section right here. I want to show you this in particular. Okay. I can see that our focus is off a little bit, and that's kind of cool because I can fix that by doing a focus run. And we've captured 8 images, but I'm actually going to, first of all, I'm going to name this, but I'll do it by letting it do the naming for me. I'm just going to do this. It's going to say Lagoon Nebula and M8 Lagoon Nebula. And then I'm going to say, make that the target name, and that'll change my name up there. Okay, now I'll also save this image with annotations so that if you wish to go back and see the data about this, you can. So we don't need it anymore, so we're going to get rid of it. Now what I'll do is something crazy. I'm going to get out of this and go back to our 1 second low light mode. And I'm going to do a focusing run with the telescope. So I'm going to do this, maximize, and I'm going to, we're still guiding right now. So I'm also going to now move the focusing. And to do that, I have my focuser on here, and we're going to go positive by a little bit. You'll see it moves a little bit. All right, and that of course changed our ability to guide. So I'm going to tell it to stop right now. All right, and actually that looked like that kind of helped us, but I'm going to go positive one more time. That's what we want. Okay, and now what we're going to do is we're going to come into our focusing, and it picks out stars, and we've got 12 stars picked. And now we're going to go, because we went in the positive direction, we're going to go in the negative direction and build a curve. So pretty cool. Isabella, it's really good to see you. It's true. Yeah, she says that's cool because I can fix it. I did say that. I wouldn't be saying it's cool if I couldn't fix it. That's why. So yeah, I can fix that. Yeah. Isabella, I think I mentioned the news, but we're going to get a 14-inch Celestron Edge HD, top of the line Celestron. And that's going to be in another building here in Benson. It's going to be in building number 6. We're in building number 1. I thought we were in building 0, actually, because 0 was on the door when we moved in, but it's actually building 1. So we're in building 1, and building 6 will also be ours. And next week, on Thursday, I head to Colorado, and I'll be actually speaking out there, but I will be doing an inspection of the site too with the owners of the property to see the prospects for putting a telescope out in a Bortle 2 sky, which is the only darker by 1 level. It's one of the darkest places in the country. All right, we're going to set the best focus here. And then we're going to hopefully work toward the goal of doing that if they still want us to do it. It seems like they do. They mentioned it. Okay. So now as this stabilizes, you'll see we're going to be perfectly focused. So that's good. Our focus is nice. Now I'm going to bring our system, I'm going to bring our stars and nebula back down, kind of centered, because I want to kind of show you this central portion of this nebula. There it is. That's what I want to show you. Now we're going to go back here and turn the music down just a bit. And then we're going to take another photo and do a first of all, get the star. I'm going to do that. Very nice. That's a perfect star. Okay, good. All right, so now we can do this again. Again, there's that hourglass-shaped central portion of the nebula where temperatures are so hot that it would vaporize your skin. And now, I know, what a thought, huh? And now we're going to do a 25-second photo again. And this time, it's going to be beautifully focused. And we're going to go into our low light mode right here. Okay. Let's see what's going on here. And I'm not doing anything there. This is still good there. We might be getting a little winds. But there's supposed to be 1 to 2 mile an hour winds, but we can get gusts. Okay, so here it comes. 1 second to go. And... oh, look at that. Stars are beautiful. Got a little bit of movement on the stars. So I'm actually going to delete this because we got some movement. And that's what that problem was. There was some movement. Isabella says it can vaporize your bones. Yeah, she's correct. She's correct. That's much better. I want to also give Isabella some kudos. She actually did a research paper, which I read, and she basically did a study of a sighting of an anomalous object she saw when she was at the linear no, it's a circular accelerator, isn't it? The Stanford Linear it's Stanford Linear Accelerator Complex, I believe. SLAC. out in the Menlo Park area of California. Look at this. And it was a beautiful, very well written paper. I'm telling you, man, that lady is a researcher at heart. God, we all gotta love that girl. All right. Look at the beautiful images here. Now, this is our narrow field system. And let's, we only have 3 images stacked, but I'm going to zoom in here because I want to show you this part right here. If you look right there, look at that feature. That is so interesting, because that right there is showing us some really cool interactions going on inside this nebula. Because this hot star is sending out radiation in all directions, in all directions, 3-dimensionally. And so this part here, you notice that there's a cluster here. This cluster that we're seeing up here, okay, in the upper part here, that cluster is a young hot cluster. And great, now this is going to be the problem with the blue Walker type stuff as well, along with the Starlinks. We're gonna have our images ruined by satellites a lot. So the blue Walker, I'm sorry, the cluster is actually also sending out copious energy, which is helping to illuminate this cluster, or sorry, this nebula. The brightest spots are from that one star right there, but this cluster is actually causing a lot of the other ancillary glow that we see. So it's really cool, and I think that's pretty cool. Isabella, I need to know where your paper's getting published so I can put it out there, please. She's going to publish it in a couple days, she says. And it's the SLAC, Stanford Linear Particle Accelerator. Okay, so let me get my ugly mug out of this here for a minute. Let's just drag me out of here. Okay. Now we're going to do something else. Because this is such a pretty picture, I'm going to actually drop this down and let this go full screen there. Look at that. Ah, that's beautiful. Yeah, this is a beautiful image. And so as we zoom in on some parts of it, you can see other things going on. Like you can see some of the sweeping motions here. These motions are caused by stellar radiation that's pushing the gas around, and we're seeing that right here. This dark lane, this is actually dark dust. This is not a void in the gas. This is dark dust. And this stuff that you see here and here and right here and here, that's here in the foreground. And that other lane of dust in the background, that's in the background going through, and we have dark dust in front of dark dust. Isn't that something? We see a lot of that. Here we have dark dust in front of the hydrogen cloud that's glowing. And there's a few really interesting things in here. Among them is this one right here, that little dot right there that you see up there. That's a very important spot because that's what's called a Bok globule. Bart J. Bok was an American astronomer. He's a world famous man. He taught me astronomy at the university as well, and these globules are very important because what they do is they're actually local areas of dark dust and gas that are condensing gravitationally on themselves. And we know that in our nebular hypothesis that the sun formed this way. The sun formed from gas that was self-collapsing, and that's what we saw here, and we see that happening elsewhere. Well, it's also happening right there, and who knows what's going to show up in this spot eventually, but we might get a young star system in there, and the dust might get blown away, or we might get a star system with a planet or planetary system around it, because that's what happens in these Bok globules. So we're literally watching potential planetary formation occurring right here in this little tiny area. Now you might just say, and I'm sure some of you are saying this in your heads, what in the world is the James Webb going to look at? Is it going to look at these things? And the answer is absolutely yes, it will. And it'll be able to visualize what's going on inside those clouds. And that's really important. Now, there's so much going on inside these clouds that it's really kind of hard to say that with any certainty that it's going to be able to get to it right away, because there's so many things in so many other clouds to look at. So it can only look at so many things, you know. But that said, I think it's pretty cool. And so this beautiful nebula, and let me give you some stats on this nebula. I think that's kind of cool to do. All right, so the Lagoon Nebula is at a distance of around, it looks like the hourglass region. That hourglass region is about 40,000 or 4,077 light years away. So we're seeing it as it was 4,000 years ago. I can just move this over a little bit to kind of show you. There it is, the hourglass. Okay, so we're seeing this as it was 4,000 years ago, and it's right in our Milky Way there. Now, there's another beautiful object we're going to look at next, and we've got a number of frames here. How many? 17 stacked. We're going to go to 20, and then we'll stop and move on. But I'm going to first of all save this and save it exactly as seen. Michael Hedrick, what's happening? He has a question, and by the way, all caps. That's my rule. You're okay. You can write in all caps for questions. That's great. As ham radio operators, brother and I were wondering what you think of the current solar cycle. The current solar cycle really has yet to truly interfere. I mean, it had several days where the KP index was really high. The KP index obviously being a measure of solar excitement. And those days did cause interference, caused ionospheric bulges and so forth. But they weren't long lasting. They certainly weren't like, the unfortunate events that have happened in the past, where there's been a massive blowout of power and so forth, and there was blackouts in the whole East Coast due to solar charges diving into the ground and traveling through bedrock, blowing out power stations down the eastern seaboard. And that did happen. I remember that. That was something else. Look at this object right here. Holy cow, look at that. What a beautiful little detail in this nebula. Let me bring this up if I can a little bit. And now let's zoom in. Here's something we haven't seen before. This is new to us. We see all this subtle veining of the dark dust inside of this cloud. Really detailed stuff. Oh man. C&D boy, yeah. It is an amazing view, isn't it, man? It is, Bob. Okay. That is amazing. Of course. You're welcome. Yeah, so moving through this nebula then, there's a lot of dynamics going on here. This star is responsible for moving a lot of the gas. You can almost see that it's blown a lot of this gas out and about. But other forces have conspired to keep it from moving out in a spherical manner. When a cloud moving out in a spherical manner hits a dense area, like over here, then that cloud is shunted and it's forced to slow down a little, so it might look more flat because it can't do it, but the outer edges can still go, and that's kind of what we're seeing there. This stuff here also very somewhat symmetrical, but still not quite. And if we back out, get a better view, you can see how this continues all the way around like this. This here would be a spherical sphere of material moving out from this homunculus, this hourglass feature that's in the middle here. And if not for the density of other material, dust and gas in the interstellar medium that's causing it to be misshapen, it's like when you drop a droplet of dye into water and you swirl the water. The swirling of the water currents can change where the dye goes. Well, that's kind of what we're seeing here. You know, some areas could be denser, some areas could be not as dense in these nebulae. And when I say dense, what does that mean? First of all, the densest dark nebula, like inside of one of these Bach globules here, the densest part of the nebula is where you may have, in a cubic centimeter, a sugar cube size, you may have, say, 30,000 atoms. Now, you might say, wow, that's a lot of atoms in a sugar cube space. But keep in mind that air, for instance, has somewhere along the lines of 10 to the 19th atoms in a cubic centimeter, or say sugar cube. Eliza, thank you. That was very nice. Thank you so much. Wow, what a kind gesture. Thank you so much for the donation. Wow. So that 10 to the 19th figure, it fluctuates with air density. But the thing that's interesting is stellar nebulae never reach those kinds of densities. You know, and when we get inside of a star, that things change, okay? So things will change inside of a star at the cores where it's very, very dense. And depending on the kind of star, a white dwarf, for instance, very, very compressed stellar core remnant of a star that went into a planetary nebula and left a remnant behind, the core, which is no longer doing fusion. That is made mostly of carbon and oxygen atoms packed very tightly together, and it's being held up by a process the electrons are doing, which are pushing back. Imagine checkerboard squares, and you have one electron in each checkerboard square, okay? And that is as many electrons as you can put in one of those squares. You can't put two. So once it's full, it's full, and anything else trying to come in it's resisted by those electrons. It creates a pressure called electron degeneracy pressure. That's what a white dwarf is held up by and held together by, is electron degeneracy pressure. That's what keeps it from collapsing further, all right? Because the electrons are all pushing back because they're packed. Now, but a white dwarf is not the end state because we also have the end state of a star that's bigger than our sun. A star around our sun size will be a white dwarf. And that is a star that goes supernova. That'll leave behind a neutron star. Now, if we had a teaspoon of white dwarf matter, it would weigh about as much as a car, 2,000 pounds. A teaspoon would weigh 2,000 pounds. That's a lot. Okay, that's how dense that is. But a neutron star density, if you could put it in a teaspoon and weigh it on Earth, it'd weigh 1 billion tons. 1 billion tons. Isn't that crazy? Wow. So I think that's crazy. JSCO, thank you so much for the donation. Wow, that's cool. It is a return to streaming. We're happy that we got this clear night out there. And we're going to continue to do this on as many clear nights as we can get. And we're going to be doing a lot more. Now, I am also going to move the telescope here, the wide field, to show us a couple more things. We'll see the same thing with the narrow field, things that the wide field can see from its position. We didn't have time to raise it up higher, so that's why. But we will. We're going to get it raised. So this is it. This is the beautiful one. We have 35 stacked here, a little more than that now. What I'm going to do is I'll bring this up. This is now this here. I'm also going to fit the height here so now you see the whole image. Look at that. Look at that. Now you see me look this way, okay? I'm looking at the observatory feed. I have a big curved screen over here. I have both observatory feeds. I have this one and I have this one, okay? And they're on the same screen. So I'm seeing the live feed, and then over here is the broadcast feed. This is where you are, okay? And I'm watching you. I'm watching both. All right. So when I'm on the actual broadcast screen when I'm doing these things, all right, helping you see things on the screen. But when I'm looking over here, I'm seeing the same thing you are, exactly the same thing. Okay. So now we come in here, all right, and let's see now. I have to look at something. I'm gonna just bring up something right now. And you see all that stuff flying around. That's dust. Because right now there's no clouds anywhere near us in Benson right now, so that's just dust flying around and insects. Okay, there are some pretty heavy thunderstorms up northwest of Phoenix, so we wouldn't be able to run the wide field system out in the Sonoran tonight because it's just not going to work with all the thunderstorms. And we don't have thunderstorms where we are, luckily, for one day. It's amazing to us. And then we have Sweariv, how are you? What's going on? How many times have you caught UFOs and UAPs? Isabella says more than Mark admits. Not true. I actually caught one which if you saw the Y-Files basement episode number 10, there was almost 1 million views on that show I did out there in Vegas with AJ Gentile. I showed him a video we captured in our observatory all-sky camera, and the all-sky captured an object coming across the sky and then sharply turning, and it looked like a satellite. There's one glow, and when it was near the horizon, the sun had set about 20 minutes earlier. You saw the sun illuminating it very brightly as it crossed in from the west, and then as it came further in toward the east, it started to fade like satellites do. And as it faded, it suddenly turned, and I noticed it had a companion that turned with it. I have no idea what that was. Now, could it have been a black project up in space? Yes. But it was most likely up in space because it was fading just like a satellite and was a singular point of light. No other lights, no FAA lighting on it whatsoever. Okay, so it was really impressive. And that's one that I just can't explain. And I asked, as most of you know, I'm on the television show The Proof Is Out There on History Channel. Season 6 going strong, with more to come, I hope. And I'm gonna suggest my sighting as one to have analyzed by the other experts on the show. All right. I'm gonna run it through our MUFON folks first, because the photo analysis team in MUFON is we have 2 divisions now that I run. We have one in the United States and we have one overseas, and so we have domestic and foreign. And I run the groups, and I'm gonna have them both look at this video and try to figure it out too. And because I don't just make a pronouncement in a vacuum. I said I don't understand what it is, and I'm pretty sure I'm gonna enjoy what they have to say, So I don't know. I mean, I think it's pretty cool, and at some point I will show you in the stream. No, I don't think tonight, but we got too much to do. All right, let's take a look here. Let's do one more look here. Let's jump in and zoom in to here. Hey, DK, thank you, brother. Thank you so much. Look at this gorgeous detail in this cloud. Do you see how it has knots in it? These knots are very important because they show local concentrations of gravitationally coalescing areas. And this gravitational collapse, self-gravitational collapse, is the secret of stellar formation and planetary formation in the universe. And we're seeing it potentially right here. Isn't that something? This is starting to collapse. This is a filament. Okay, then we see collapse starting here and here, the denser areas. Now again, at this point, the densest areas go from anywhere from 30 atoms in a sugar cube size to 30,000 atoms in a sugar cube size. Remember, air is 10 to the 19th atom, so a long way from those densities. If you were going through this cloud, which is a couple light years long, by the way, if you're going through this cloud, you might not even know you're in a dust cloud. Such is the case that we may be in. How about that, huh? You know the Pleiades, when we take photos of the Pleiades, the seven sisters, you notice how they have the bright blue stars, and their blue light is reflecting off the dust that they're immersed in. Well, they're immersed because they're just passing through the dust cloud, which is going a different way than the stars are. So that the stars and the dust just happen to be mixing with each other at the moment. And the thing is, when you look at that dust cloud, it turns out that maybe that dust cloud that the Pleiades is in right now, which is a dust cloud that's 400 light years away from us, well, maybe that dust cloud extends all the way to us. And maybe we have been looking through dust forever and not known it. Forever as far as humans are concerned. It's because it takes millions of years for the dust to move away or out. So we might be missing an awful lot of the universe, or a part of the universe anyway. Or we might have distances messed up by the light being reddened and making us think things are farther away. I had to just take a drink. I'm sorry. I'd offer some for the whole class, but I don't have enough. Okay, so let's jump back out of this then. We're gonna save it one more time. There's 52 images. This is gonna be a beautiful, beautiful processed image. For those of you in our Patreon, if you join our Patreon, you can see up there, please consider being a Patreon member. At I believe $10 and above, you get a month, you get 4 of our images like this, highly processed, worthy of framing and beyond. And we also do have a fine arts dealer that works with us, and will take our images and put them under glass, put them on metal, put them on canvas, and frame it all. So there's all kinds of things. And if you talk to Marianne Robb, she will tell you that she has a whole room filled with our framed and canvas portraits, because that's the Sky Tour home base at that location. So this is beautiful, and this has a lot of depth. Now I'm going to do one more thing. I'm gonna actually do this. I'm going to darken it up a little bit so we can see a little more detail. And you can see in here we got some light and dark detail going on in here that's really nice. Wow. Unbelievably beautiful. So so we might be looking into a deep hole. And these nebulae are 3D, not 2D. Okay, so this dark nebula might not see this at all. Okay, this is probably out in front of it, and this is out behind it somewhere, for all we know. Okay, well, I will do this process right here. Okay, and then bring this up a little brighter, get it to where I want it. If we brought it way up, it's going to look blown out, but you'll see the dark stuff really outlined nicely. See that Bach globule is looking really bright there. Okay. Now, also, what we do sometimes is we go and we invert it. Okay, and when we invert it, then we see the dark nebula as light. And that actually helps us see things. When I was getting my degree in astronomy, everything I looked at was like this. We never used photos that look like what you love to see, which is, of course, this. We always used the negatives because they were better to measure and study than the dark, because where the dark ends, you don't quite know, but when you see it in a negative, it's pretty clear. Okay, we're going to save this at 59 images. And save it exactly as seen, and move on to the next item. Next thing. Okay. Say goodnight to the Lagoon Nebula, at least this part of it. It's way bigger than that image shows. And then we're going to go back to our low light mode now, and we'll do that here. Okay, and now in our low light mode, let's kick it up. We're going to go and move up the Milky Way a little bit, and we're going to move to the Trifid Nebula, which is right near it. And it is, oh wait, it's right here. Right there. It's right nearby. And now when we come here, we're going to see something a little different. Okay. First of all, what we're going to see is that I've got to stop us guiding here. Okay. All right. And when we come to the Trifid Nebula, let's do this. Stop it. Okay. Yeah, do that. Okay. All right. And now what I'll do is get rid of this and pull the Trifid directly into our center of the frame, which is important. Okay. Now you can see it there. Now it doesn't look very bright here. That'll stop moving in a minute. And the reason it doesn't look very bright is because we're going to have to take an exposure of it. And that exposure is going to bring out the details that we want to see. Alright, I'll do that. And this is just a beautiful nebula, as you'll see. And we're going to go down a little more because the blue extends upward. There's blue in here too. So we see two different kinds of nebulae. Now we saw a hydrogen emission nebula just now. And what we're going to do now is we're going to look at not a hydrogen emission nebula, but we're going to be looking at a hydrogen emission nebula and a reflection nebula that operates similar to the Pleiades. All right. And so that's what we're going to be looking at right here. So let me just bring this over. All right. And that should be good. Maybe just a little more. Okay. All right, I think that'll do it. So now let's go get our guide star and see what we can do with that. And let's do this. Bring our stars up so you can see them. Look at it, we got a galaxy right there. See it right there? Little galaxy in there. Okay. I'm going to do this and grab our stars. Beautiful. That's a great star. Okay. Perfect peak. See that? We want those nice peaks. All right. Now let's go see if I have to move this at all. We're going to take a 25-second photo of this as well. All right. And we're going to go into our live stack here. And we're going to set to fit the height. There we are. Okay. And 1 second away. And boom. Okay, look at that. Now, okay, so we're looking this way, so I have to move it. So I'm going to move it up just a little more. Don't worry, you're going to see it again. All right, so now we're going to move this up. Yes, I know. We'll get you back, Mr. There we go. Okay. All right, so now we're going to come back here. Stoppy, stoppy. Reacquirey. Starry. And that's beautiful. That's a good star. Look at that. That's the best star. Wow, nice thin peak. Yeah. That's what we want. Okay. Okay, so now let's do it again. The blue is going to be here. So I'm still getting used to which way this mount shows our objects. It's a little different from what I'm used to. Why is it? Oh, we got some wind. How about that? Okay. Right, we're back. All right, let's do this. Just as I did that. All right, so 25 seconds. And off we go. There we go. And we'll live stack this. We're going to come out of low light mode. And now you're going to see this red hydrogen emission nebula with these dark lanes. This is called the trifid. Tri for 3 lanes of dark material. And then the view is going to be one of the emission nebula, and then below it is the blue nebula. There it is. This is something else. Now let me make an adjustment here. Notice our black level is in the middle of the curve. We want to move this to the left of the curve to get that. Okay? We want to color correct it as well to get that. All right, so now we have some beautiful imagery. This fits this frame perfectly. All right, so we have 2. So there's the blue. Now, as we do more of this, you'll see this blue actually extends all the way around. It's almost like this is a red object kind of immersed in a blue reflection nebula. So the stars here and the stars responsible for causing this to glow, you notice it's kind of evenly distanced from those stars in the middle there. That's because those stars are the ones that are powering this nebula, and the stars here, where there's undoubtedly also hydrogen, are not powerful enough to cause the hydrogen gas to ionize and do this process of recombination, where the electron comes back and gives off red light. So the glow can only be done out to a certain distance from the hot stars, and these stars are beyond that. All right, but you'll see the dark stuff in here, and as we get more here, we got 4. We can actually pull this in and see even more detail in there. Now this dark stuff is showing up. You can start to see blue here. This is a beautiful nebula, and again, notice this object right up here. We call that a pillar. All right, and that's created by hot stars that are forcing, with their radiative winds, forcing dust and gas to be pushed away from them. And when they do that, only the dense areas can withstand it. And right there at this area here, this is likely a denser knot of gas and dust. So it resists erosion from the stellar radiation way more. And so that's why it sort of stands out here, right? This here is up here in front, and the rest of the nebula is back here behind. If you took those out, this would be a roundish nebula. All right. So this is just a beautiful object. Now, we can, when we used to not have color film, and we used to film in the old days, when in the late 1800s, this is what they got for a picture. They got something like this in black and white. They didn't know that this was blue and this was red. They didn't know exactly what it was, but only after they got color film could they do this. Now, of course, with our digital technology, we see this all the time, and we're just totally used to this, and it's actually pretty cool. So this is the beautiful Trifid Nebula. I think that's pretty cool. Isabella says, I'm not a fan of the Trifid Neb. It always looks more angry to me. It's funny how all nebulae have sort of personalities. That's actually kind of funny. That's interesting. I'll tell you why, Isabella, what's funny is I wasn't a fan of it when I was looking at it through the wide field system, because with the wide field system, you don't see all the detail in here that you can see with this narrow field system. And as we're speaking, I'm trying to over here see if the wide field can actually see the Trifid Nebula. It's a little higher, so it might maybe be able to catch it. I'm not sure. So we're gonna see. I will let you know. It'd be nice if it could, because I'd like to show you. I mean, you'll be able to see other elements as well. Okay. Oh, so we'll let more frames come in here. All right, and more frames coming in here. That's good. That's beautiful, though. Look at all the detail in here. Such a beautiful thing here. Michael says, what is that alien doing in the green? What green? You talking about this? This is blue. You don't see that, do you? You do not see that. Okay. Interesting. That's pretty, though. That's 13 frames captured now. Let's drop this down just a bit. Let's pull our dark frame all the way up near the top of the curve to really accentuate that. Look at that. Really accentuates this, doesn't it? What a pretty shot. What a pretty look. Wow. That is unbelievable. Hoo-wee, DD. Yep. And then, I'm just thinking that's something else. Wow, what a pretty shot. Isn't it amazing how much that is really coming into its own right now? Notice how we got the 16 shots, and now notice this dust is just so pronounced. You can see it very, very nicely. That's amazing. Wow. Absolutely beautiful. I find that to be just amazing. Yeah, that's right. Great wallpaper too. Absolutely true there, Bob. Wow. Oh yeah, man alive, that's just something else. So again, you can see now that there's blue around here. This is just such a beautiful shot. Now we do this, you can see it gives us the Trifid Nebula Messier 20. Charles Messier in the 1700s cataloged this as not a comet. Don't look at it. He was a comet hunter. So he came up with a catalog of objects that were not comets. And therefore he said, don't look at them. They're not comets. Would you not look at this? My gosh, it's such a beautiful thing. And there's so much going on here. So much that this particular object has taught us. Okay. We've learned about dark lanes with this. We've learned about pillar creation. We've learned about interactions with reflection nebulae. Okay. We've learned how dark dust interacts with the interstellar medium. It's just incredible, you know. Amazing. The wide field system can't look at this object at the moment. Once I raise it up, it will. Well, but it can't right now, unfortunately. But it can see some of the other objects further up in the Milky Way, and of course out in the Cygnus region, which is actually overhead as well, which is just great. Cygnus is beautiful. We're going to look at a couple things there. And being that this is like one of the rare clear nights out there, I'm not in any hurry to end the stream, I can tell you that. So I'm good right now. Right now. If you see me fall asleep, like, oh, you know, then I'll wake up and go to something else. All right, so let's there's 23. Let's come out here for a minute so you can see the whole thing. Okay, there's the whole frame. Look at that beautiful image. Isn't that gorgeous? Try a color correction, just get a little bit of a change of the curves. Look at this dark dust in here. Gosh, you just gotta zoom in on that to see that. See these areas here, possible self-condensing, self-collapse undergoing there. And then we have other objects like these pillars here, this pillar I should say, this dark dust. And this dark dust is probably in no small way affected by the hot stars here. That may be causing a lot of what we see here. You know, Sean Paris, what's up, man? Nice to see you. Yeah, I didn't get a whole lot of sleep last night, but then again, the weather was bad. I was outside videoing the thunderstorm, of course, and it was a potentially severe one, so I was outside under my porch with the camera, and I saw a flash and heard a crash at the same time, and I got an alert. Lightning just struck 0 miles from your house. So I took my drone up in the air today. I got a DJI Neo. I have a whole fleet of them here. I've got a big hexacopter carbon fiber, and that carries cinematic cameras and everything. But this is a little guy. Just take it up, you know, with goggles, fly it around in the, you know, first-person view. And it can make you sick too when you're driving along. You're like real low to the ground, and curve away. It's like, oh, your brain says, we're moving. Love it. Anyway, the DJI Neo, I took it up and I was looking because I can get really close. It's this big. Actually, it's right here. It's this right here. This is it. Okay, and I was able to take it up and look at the storm damage, and I could see trees that lost limbs and stuff like that in our backyard here. What an amazing storm that was. But the lightning strike, that was incredible, because it was like boom. As soon as you saw the flash, you heard the bang, and the whole house shook. And I thought maybe I got hit again, because we got hit once before, and it was in the middle of the night in bed, and the ceiling fan was going, and we saw the lightning, heard the thunder immediately, and then the ceiling fan shot sparks everywhere. I had to put out little sparks on the bedspread. And when that happened, the ceiling fan stopped working. It's like, okay, well, I guess that's it. Well, it got destroyed by the lightning, or so I thought. 6 months later, out of nowhere, it started working again. It just started going. Like, okay, time to change this thing. So I changed it to a better one. And a new one, and there was no damage to the wiring. So and the house is grounded well, but this was just a particularly large bolt that went many different directions. Okay, let's do this with that too. Put that down and tell it to fit the height. Look at that. Wow. Now that is a cool nebula. That is a cool nebula. These amazing dark lanes here have always intrigued me. Now in a small telescope, you can just barely see them, and you see this little area right here that's made by these stars here, and you see that, but you don't really end up seeing any of these dark structures out here with your eye, unless it's a fairly large diameter telescope. But this stuff here, this green nebula, this is like I said, a reflection nebula, but in actuality what's going on is not reflection. It's actually scattering. What happens is the light hits the little tiny grains, and light is composed of a whole spectrum of light: red, orange, yellow, green, blue, indigo, violet. And the blue light, because it's higher frequency, the blue, indigo, and violet light is absorbed and re-emitted. It's like a perfect match for these little dust grains, and they just love the blue light, but they scatter it in all directions. Now, in the same way that happens in our atmosphere, I've told you this many times, and that's why our sky is blue everywhere we look, because everywhere we look, we have these molecules in the atmosphere that are scattering the blue light from the sun. And that's why traditionally throughout school you were taught the sun is a yellow star. Well, not if you go into space. If you go into space, the sun is almost white. How about that, huh? We've been doing it wrong all these years. And because some of the blue light is taken out of that red, orange, yellow, green, blue, indigo, and violet, the light is shifted a little bit more toward the yellow and red side. So the sun looks a little more yellow. But that's just an Earth-based, observation, and it's not an actual truth. It's also why when the sun is on the horizon in the morning or in the afternoon, late in the sunset, the blue light, more of it is taken out of the sun's spectrum, and so the sun looks more red. In fact, the sun can look blood red if we have a lot of dust in the air, because dust does the same thing as this stuff does exactly, and so it scatters the blue light. All right, so this nebula looks blue because of scattering. Now, hydrogen emission can overpower scattering, and you can end up seeing hydrogen emission before you see the scattered light, and sometimes they mix together, like with the Running Man Nebula just north of the Orion Nebula. The Running Man Nebula is a blue nebula, but inside of it is an emission nebula like this. And so because of the way light works when mixing colors, when you get a blue nebula surrounding a red nebula, the red nebula looks magenta in color, because that's the complementary color with light. Not with paint, but with light. So, pretty cool. All right. So, we are good with this guy, and we're going to move on to the next guy. And this is going to be kind of fun. Let me take it out of here, and I'll save this. Got my identifier. Save it, and then save it exactly as seen as a PNG. This image right here, you can get online for free. Just go to skytourlive.org, scroll down to I Want Cool Pictures, follow the instructions, go to our live actual research database, and you will be able to download the image we just took now. It's going to be there. If not there already, it'll be there in just a few seconds. All right. Now, let's go to another thing that I want to show you. Say goodnight to the Trifid Nebula. All right. We'll go down to our, go here, go into our low light mode, and you'll see a little bit of the Trifid there. And from the Trifid now, we're going to run up to another object that's up here. And as we zoom out a little bit, it'll become clearer. So we're in Sagittarius right now. And we're going to move up the line here to this location. This is the Omega Nebula. This is a beautiful tour item. And we're going to go there now. And as the telescope moves up an atom, there's the Omega. Now, the Omega is visible in the wide field. So we're going to go see it in the wide field first. All right. It'll stop as it stabilizes. We have to wait for it to just slow down and come to a stop like that. All right. And then we will bring you the rest of the nebula in the wide field. You can actually see it all, which is really cool. Okay. Now, we'll come back to this. For now, let's go over here. Here's the Omega Nebula. And we're going to do a... let me make sure I got my guide star going. I don't, so we're going to get a guide star. And now we should see our guide stars. Okay, let's do this. Oh, how about that? Let's try. All right, we're gonna quit that because it's not reacting right, and we're gonna bring it back. Always have a way out. Okay. There we are, and now we'll connect. All right, connecting. Take a 1-second photo. Oh, are we still? Oh, the telescope. Oh, the guide camera is below the level of the building. Oh, darn it. All right, well, you know what? We'll just do a quick one anyway. Let's do this. We're going to go and do a 25-second photo using this system here. At wide field, there's no wind, so it may come out okay. Telescope isn't the problem. All right, so let's now go and while that's coming in, we're gonna go check out the other one. Actually, we'll wait for this one to come in. Why not? We're almost there. Let's check it out. Okay. As we get a second one, it'll be a lot better. I'm gonna try this now. Yeah, that red is that's the top edge of the building. So we're still getting a little of the, that's why. But look at that. It'll be useful. That's why it's so messed up here, because we're getting all this non-data. All right. So what we can do is take this over here. Yeah. And then, so that's the Omega Nebula that we're looking at there. I can't wait to raise this up, I'm telling you. Let's actually get it to center it. Okay, so this is Messier 17, the Omega Nebula. I'm going to set that target name. Okay. All right. And we'll let that percolate for a few moments, and we'll come over to this guy, and we're going to pull him back in. There we go. All right, let's get this centered up here. And let's grab this guy. And why is it doing that? It should be... It's like it's not tracking. I'm going to turn it off and turn it on. Okay. That fixed it. Nope, it didn't. I'm wondering what's happening there. Okay, let's try moving it down a little bit. That's the other down. All right. Yeah, I don't know why it's doing that. Hold on a minute. Stop. Maybe it's trying to move it. All right, let's do that. And put this back. Put it back. Okay. Okay, the Omega Nebula is just a beautiful nebula. We gotta check it out. So we're gonna grab our stars here and grab the guide star. That's a perfect star. Boom, look at that peak. Perfect. Okay. All right, so now we're gonna take a photo of this guy, and this one's gonna be again, 25 seconds is all we need. All right, off it goes. And we will come out of the low light mode and go into the stack mode right here. And I'll just add that in here. This is going to be M17 Omega Nebula. While we're waiting, I'm glad you guys are enjoying this tonight, because I certainly am. Now, look at that, beautiful. Look at that. I'm telling you. Again, while it's percolating, let's do this. Let's fill the frame with it. Why not, right? So that's just one 25-second exposure with the Sky Tour system. Now that's just amazing. Absolutely stunning. I will do a color correction. Get that moved just a little bit. And then this is just about right. I'm going to move this down a little bit so we can actually see a little more of the detail in there. Look at that. Wow. Isn't this amazing? Yeah, this is gorgeous. Kathy Messick says, "Whoa, stunning." JSEO, very cool. Wow, that's pretty cool. Yeah. Mike has a fun fact. With all this new technology, I like looking at the old newspapers. It's hilarious. It's like Facebook. Yeah, it's kind of like Facebook, except it doesn't dynamically change in front of you. Every time someone visited someone, they'd be in the newspaper. Yeah, that's true. That's very true. You can read old newspapers on microfiche at libraries, or actually subscribe to real newspapers. They still have them, believe it or not. Kind of a dying breed. All right, so what I'm going to do now is I'm going to, you see this. Here's what that looks like in the wide field. All right, see how much smaller it is? Now, yes, the wide field's polluted with this top of the building right now. That's what we're seeing there. It's almost out. All right, but I didn't expect that would be the case. I might have miscalculated the altitude of visibility. Sorry, but that said, we're going to change it. We only have to literally move it up by literally a concrete block, for crying out loud, and it'll be fine. Okay, so let's do this now. Let's go back. So you see that, and it's different because the telescopes are aimed differently, right? But that, what you're seeing there, if you take that and move it this way, okay, you get this, right? So you take this and move it that way, and we get what the other telescope sees. right? So it's the same view, the same left and right. There's no swapping or whatever. But look at that. You can see some subtle changes in the nebula over here, which are really pretty. And it illustrates an area where the gas is not as dense. But what's happening here, which is really interesting, is that this entire area is dark dust. This entire area is dark dust. This just happens to be peeking over the nebula. Okay, so it's obscuring a little part of the nebula. And this dark dust in here is now, that doesn't mean all of space is dark dust. It's not. But in this particular region where the Milky Way is, we have a lot of dark dust. And so we see a lot of it interacting with our bright areas. Isabella says, how amazing it would be to be able to travel just a few light years away and look at the nebula from another viewpoint, or even from the other side. That's true, and you can do that a little bit using Space Engine. Space Engine affords you the ability to do that because it is one of the best 3 space approximations of the universe that you can use and get. We often will do a stream just with Space Engine and show people that, very cool stuff. With Space Engine, for instance, you can go to the Pleiades, immerse yourself in that blue nebula, and then rotate it around to see how the stars look from every other perspective. That's really cool to do. So you can see how if you just move 20 light years to one side, the Pleiades don't look like the Pleiades anymore. They're a weirder looking collection of stars. That's neat stuff. We look at this. Wow. Again, the Omega Nebula. And what I'll do now is I will get the Omega Nebula centered up. I believe that I've already defined it, so I don't have to do anything. I'll just save the image with annotations and get rid of that. And then I'll save this. We have 14 images. We'll go to 15 on this. Again, this will be available in just a few moments. I used to be bored by the Omega Nebula gang. Get this? I was like, I don't know what's going on. It just doesn't look that exciting to me. And then when this telescope came along, thanks to Ronald, who was a donor of the funding to get this particular scope for Sky Through Livestream, I visited this nebula in a whole different light. No pun intended. Unbelievable what you can see with this. Really is. You get all kinds of gorgeous interplay of this nebulae, light and dark areas that we just can't see when we're looking at it from this vantage point. You can't see any of this detail in here. Okay, none of this detail is visible to us when we're looking at it from so distant a view. But that wide field telescope is good for other things, as you'll see. When we use that wide field telescope, we see things, and we see it in the light. I'm sorry, we see it in the in a 1 degree by 1.5 by 1 degree size field of view, and that is just immensely valuable to us. Because then you close in on it, and so this gives you the context, and this gives you the detail. Look at that. Wow. Okay, that's 18 frames. We'll save it here. Save it exactly as seen. And then since we're almost at 19, I'll let it do 19. Alright, now we're at 19, so now we'll save it again. Save exactly as seen. Alright. Okay, and we'll say goodnight to the Omega Nebula. And now the next item that I would like to show you is a little bit different, and that is one that's right near it. And there's a couple things on. I'll show you this, then we're going to run up into Cygnus. Okay, this one here, absolutely amazing. This is the Eagle Nebula. It's also known as the location where the Pillars of Creation reside, and that is, of course, something that is extremely known to most people because of the Hubble Space Telescope. All right, and let's see here. Move this down. There we go. Let's get out of here. And let's do this. And stop. Do that again. Grab the star. That star should work. It's a good star. Okay. All right. Now, let's do an exposure here. Let's run another, again, 25 seconds seems to be all we need. Okay. All right, so we're going to do that 25 seconds, and we'll go into our live stack and go into out of our low light mode. Okay, that's something. All right. Keep a watch on it because it's going to get good here in just a minute. Wow. Wow. Now that is something else. It's upside down to us, but it's okay. Unbelievable. Okay, we'll let it percolate just a moment. Okay. Look at that, huh? Oof, man. That is just gorgeous. So these are the Pillars of Creation. They're at an odd angle because of the way the scope is. They're literally upside down to us right now. But look at that. So let's we've got, how many that we've done here so far? We've done 3. Only 3 stacked. This here is the fairy. It's known as the Cosmic Fairy. Interesting little piece. Here are the Pillars of Creation. Now, again, from what we've talked about, I talked about how hot young stars will actually erode away light, gas, and dust, but the dense areas will stay behind. And the dense areas, in this case, are right here, right here, right here, right here. You see, you get the idea? There's a lot of them. This over here may have once been part of a pillar, but it eroded away enough of the gas and dust that this particular dense globule, Bach globule, ended up surviving and is probably forming a star in here. At some point, we'll see a star form here in all likelihood, and possibly even a planetary system. It could already be underway. Look at that. Look at that. That is just beautiful. Wow. That is something else. Let me see. Our cooler, our running our chip at minus 11.7 Celsius, which is good. Yep. And let's see, under pre-processing here. right, we're good. We got that. Just checking a few parameters. We're all good. Okay, so as we look at this, you might say, well, what about in the other telescope? I mean, is that able to show us anything? Because, as I mentioned to you, it wasn't able to show us anything before. And it's the guide scope still can't see. But what we're going to do is, while that's percolating, we're going to come over here. This is the cluster again. What we're going to do again is we're going to do this. We're going to say, hey, we're going to go do a 25-second shot of this. Now, 25 seconds here, let me just get rid of the low light mode and go to live stack mode. 25 seconds on a very, very fast optical system is going to be like running 4 minutes or so on this system. So here we're doing 25 seconds. And on the other system, we're going to see not just the nebula, but all the nebula around it. Okay? And that's what makes this so exciting. Okay? And you'll see that in just a moment. So let's actually look at that. That's beautiful. Oh. See all the detail in here? You see this dark nebula? This is the hot cluster, by the way, that's actually causing the erosion of these pillars and the creation of the pillars. So again, these dense areas here, here, and here, and then other areas are holding together only because they are too dense for the stars here energy to erode them away. So they're able to withstand it. So the stars, whenever you have stars form like this in a cluster within a nebula, they form what's called a cavity around them. They actually make an open space around them as they blow away with their stellar winds all the material around them. And in this particular case, that's not really happening, is it? To these areas here, because these areas are actually being quite resistant to these areas here I'm talking about. It's quite resistant. Now, over in the wide field system, well, this is what it looks like there. So here, you can see the pillars of creation, this tiny little area right there. There's the pillars, okay? And compared to here. Now, again, this is like this, and when you come over to the other one, you have to go like that. So you have to rotate about 40 degrees. It just happens to be the way the telescope is sitting on the mount. But look at that. So the hot cluster's here, and there you see the pillars. Now, if we zoom in here, okay, we can zoom in to a certain point and say, wow, look how beautiful that looks. Well, it kind of does look beautiful, but you can't really see the detail in here that much. But if we come over here, all right, and zoom in, a very different thing happens here. When we're in here, we actually see a detail in here that's really quite powerful. All right. Not only that, we can see that this has a subtle glow to it. All right. You can see this glow around it, and that is because the stars that are here are farther back, and they're hitting the hydrogen gas that's in this cloud from the other side and causing it to ionize and glow. So we're seeing that the glow thing is over here and the stars are here. Okay, so we're seeing it in silhouette, which is kind of, thank you, Starlink. I didn't need a pointer. Okay, and in the other system, you can see that the Starlink went through as well. Yeah. This is an ongoing issue. We, most of our images get nailed like this, but over time that line goes away because the next image doesn't have it, and it has the data that's supposed to be there. And that data that's supposed to be there will actually slowly minimize and remove that light from the trail. 1 minute here. I just had to set that parameter. Okay, and now we have 18 stacked here. Look at that, huh? Isabella says, can stars in such dense clusters have planets? That's a real good question. And I'll tell you what's interesting about that question is this brings up what conditions must exist for planets to actually exist. We need to have conditions where a star can have time to form planets. But if you have stars with very, very heavy-duty stellar winds, they don't just blow away dust, out here, light years away. Okay, back here, light years away. They actually blow away dust very near them as well. And that dust and those other materials and other compounds and molecules that are out there in space are getting blown away with it. So the more powerful the star, the less likely there will be planets around it. O stars, no planets. B stars, probably no planets. A stars, occasional planets. Right? Then F stars and on down to the other stars, more and more planets. Okay? Mundus, how you doing? Nice to see you. You're from the southern Colorado Rockies. I'll be there next week. Actually, Thursday I'll be there. I'm going to Alamosa in Musca, actually. So I will be out there for the weekend doing a star party and doing talks at a conference out at 7,500 foot altitude. It's going to be great. Okay. Let's do that. All right. Neato, man. So it was actually clear in Colorado, Mundus? That's pretty cool. Now, I want you to check out the other view now in the wide field. Notice in the wide field, look at all this other nebulous detail that is out here. It shows up, and actually this is zoomed in. Let's zoom out. Check that out. Look how much is there. There's a lot there. And yeah, I realized that, we have interference from the edge of the observatory here. But I'm going to get rid of that, I promise. Because it really is bothering me. And it's responsible for the weird shape of the curve here. Okay. So if we go to like here, okay, then you see it a little better and you can start to see some of the other nebula out here as well. But it's like we're getting, I'll tell you what it's actually, what it is. You see how it looks bright in here? We don't have the lights on in there. That's an infrared illuminator from the camera. That light you see up on the right here, that's infrared. If you're in here, it's pitch black to your eyes. You don't see anything. So what I can do actually, I can do something pretty interesting. I'm gonna go and get into this, go into the settings of that upper camera. And I'm going to turn off, there we go. I turned off the bright light that was interfering. Okay. Now I could also go back to this camera and turn off the lights here as well. I say lights, the infrared illuminators, and then it looks like that. See how dark it looks? It's very dark here. So yeah, so I'll leave one set on, all right, which is kind of important to leave one set on. Okay. Alright, and let's go here. Do this. I'm going to turn that light back on. I hit the wrong status. Wow, look at that. That's really pretty. Over here. It's getting better and better. We'll add this night vision light back on. Look at that. That is amazing. What's not amazing is that I seem to have flipped the I flipped the image upside down somehow. Now that's pretty bad. I didn't mean to do that. How about that? There we go. Not bad. All right. Okay. Notice the satellite trail here is actually getting softer. Beautiful. Now let's do one thing while we're here. I'm going to come in here and see what we got going on for our unsharpened mask. Let's sharpen it up. Let's see if we can sharpen that up. Okay. So what I did was I sharpened the detail. So now you can see it even better. Look at that. You almost see this now as a separate thing up in the foreground compared to the background. Beautiful. Let's do this too. You can see the dark dust here. It's not the absence of dust. It's actually dust that's overtaking and enveloping this part of the nebula. So we're bathed in all the dust of creation here. Amazing. And this again is the fairy. It's called the cosmic fairy. It's a feature. Wow. Cool. We'll let that go a few more seconds. And then let's see if we can do one more beautiful object here. Look at that. Unbelievable. That's really nice. You can see all the detailing, the subtle detail in here. Wonderful, wonderful. Gosh, that's beautiful. Really pretty. Nicely done. Gotta say. So this image, probably one of the best we've done of this object so far, because you actually see it as like it almost looks three-dimensional, doesn't it? And that's really pretty cool. Really something else. Man, that looks really something. Real subtle detail in here you just can't see unless you have a telescope like this. Really nice. Oh yeah. Wow. We're gonna fit the height here again. All right. What a pretty image. Again, the pillars of creation, just like that. It was taken with the Hubble. Let's dock this up again. Very nice. And we'll save it with 39 images taken. Save exactly as seen. I screwed up, didn't I? Yes, I did. I forgot to do this. I forgot to tell it that it's the Eagle Nebula. It's the Eagle Nebula, silly. Now I'll say set the target name and then endure the complaints. Yes, my mistake. Yeah, so now I saved it to the bright place. I'll fix that after I come out. Okay, we're doing good there. All right, so now I'll save it and then save it exactly as seen. And we have 41 images, so that's good. Nice. All right, one more little jaunt at the pillars themselves. Look at that. There they are. This image taken by the Hubble is what started it all. Really something. Gorgeous. Wow. All right, folks. Well, now let's move on. Again, this is saved. Look at all that. That's just so detailed. It's like a cloudy. Well, just like lay on it, you know. Who cares if it's the temperature of hot stars, ultraviolet energy? Who cares if it melts your skin off? It looks so inviting. Okay. So let's now hey Toner, what's up, brother? Let's now go and let's save it with 44 because we did. And now we'll come out of here, get back into our low light mode here. Now we're going to move to something different, and that something different is going to be a cluster, but not just any cluster. Yes, it's called the Wild Duck, otherwise known as Measure 11. All right, and we will set this to fit the height. Okay, and then is it this one? Yeah. Stop this from doing its thing. Okay, let's bring you up into the middle. All right, this beautiful cluster, fan favorite for many years of many people. This particular cluster, in fact. So we're gonna grab a star or two, and let's see if we can do our thing with this. There you go. That's a good star. Beautiful profile. Okay. Meanwhile, over in the other telescope, we have that same object right here. Look at the difference in the size from here to here. So now what we'll do is we're going to basically we'll do 20 seconds on this, because you're going to see the Milky Way around this. Actually, you know what? I took that back. We're going to do 25 seconds. And let's come back here. Yeah, that's what I was hoping for. We're going to see some stars. So we're going to do this. Okay. And then grab some stars. Do that. Okay. Okay, so we are guiding in both telescopes now. All right, so what we're going to do is we're going to come back to this other telescope. We're going to set up a 25-second photo here. And off it goes. We're going to go into our live stack mode and come out of our low light mode. And in the other telescope, we are going to do that as well. And we're going to do a 25-second photo of this as well, and come out of our live stack mode. Meanwhile, in the other telescope, here is our first view of Measure 11. Again, as before, we will make it full screen so you can check it out. Look at all those stars. What a beautiful sight. What a gorgeous, gorgeous object. Just something else. There's a lot going on here, actually, and we'll cross that bridge momentarily. Let's. So, where this is in the Milky Way is it's surrounded by star clouds and dust. And so we're right in the thick of the Milky Way here. And now that our other telescope is above the wall, I can show you what that looks like. And that's this image. Now, look at that. Now, let's do the same thing we did. I'll say fit height again. And then we're going to take this out. Okay, and now we got it. Look at all the dark dust. This is all dark dust in here. All right, dark dust, dark dust, dark dust, and star clouds. You'd think for all the world that you just photographed a flashlight on a wet driveway, wouldn't you? But that's not what this is. This is a live view of a very dense part of the Milky Way. In fact, we're in the what's called the scutum star cloud. It's actually just off to the right there, out here. But this is just a beautiful location, and that is approximately the right color. Let me come in and do a color correction anyway. Get rid of some of the reddening. And then let's pull this up the curve to just ahead. All right, like that. And now you get to look like you're looking in a driveway, a wet driveway. But that's all dark dust, and you're looking, obviously, you know, I'd say maybe 400 light years across the screen, maybe 500 or 1,000 or more light years across the screen, actually. Then in the other computer, in the other telescope, this is what we're looking at, right? So we see the core of this cluster in a way like we've not seen it before. We notice also there's some red stars in here. I'm going to go here. Well, maybe not yet, but right now I will. I'm going to go here and do a color correction so we can do that. Okay, color corrected. Then I'm going to move this off the curve a little bit to bring in whatever else we could see. Now, when we're looking at it this close, you'll notice there's not much. We're seeing in our other view, we're seeing something like this. Okay, so we don't see any of this. This is a wide field system. This is what this system is built for. What we're seeing right here. That's what the system is built for. You see this amazing, beautiful night sky like this. Many degrees of sky. Well, 1.5 degrees by a degree. Okay, so basically 3 full moons by 2 full moons tall of sky. That's what we're seeing right now. All right, and in this other one, we're seeing only a few arc minutes each way. I think it's is it 30 minutes? Let's go back and see, because it tells me here if I actually grab this matrix thing here. It's yeah, it's only 20 minutes of arc each way. So that's something. Okay. So, and here we can bring that in as well. Let's go bring up this on this side and bring up our view. There we go. And now you can see we have 1:30. Okay, 1 degree, 30 minutes of arc, sorry. And 1 degree up. So we have 1.5 degrees by 1 degree in size. So cool. And let's take a look now. Look at how this is coming in. Isn't that incredible? That is amazing. Let's ID and set the target name. You're darn right, it's the wild duck. Looks fantastic. We'll set the target name, and then we'll save the image with annotations. That goes into the directory so you can see all the things around it. and then we'll get rid of it. And now what I'll do is, because we've got 12 images, I'll save these. The first save is for the astronomical file format called FITS, and then the second save is for the visual file like you see here on the screen. Okay, now over here, we're going to do the same thing. We're going to identify this right here, and it again is going to be. And then we do M11. It said M11. That's kind of funny. It identifies it differently over here. Well, that's okay. So we'll take the wild duck. We'll set the target name. Save the image with the annotations here. And then we'll come out of it. All right. And then I can save it. And save it to that beautiful shoe. Oh, nice. Okay. So obviously the wide field system gives us a broader view, shows us parts of the Milky Way that would otherwise be hidden from us like this. And this view shows us close-ups of that particular location. Let's see if we can do something. Let's do this. Let's go to our histogram here, and let's see if we can pull in any more detail around this object right now. And the answer is maybe a little, maybe a little. That's something else, though. You can see kind of the reddish star cloud, the reddish yellow star cloud here that we actually see here, right around this. Okay, we can actually see that, which is pretty cool. Wow, that's really something. Yep. Yeah, boy, oh boy, I missed that kind of view of the galaxy. Okay. Hey, Prow, how you doing? Nice to see you. Okay, so now what we're gonna do is save this, and I'll move this up a little, and then save it exactly as seen. Okay, and then we'll come out and move to another object that's up in the Cygnus Milky Way, which I think is pretty cool. Although I do want to show you the North American Nebula. Oh man, with a wide field, it's just stunning. Narrow field, not so much, because it can't. The wide view sometimes is the best telescope to see something. But what we're going to do now is we're going to come over here, going to back out of this. We're going to ride up the Milky Way here. That's Sagitta. We have the Dumbbell Nebula here, which we'll look at next time. But this is almost directly overhead, which is why I want to get at it now. And that's going to be the key. We want to see the Crescent Nebula. Because it's up, right up high in the sky. Yep. And that means we've got a lot to see here. So off we go. Telescope is moving. All right, I will take that down. All right. Now let's see. Let's make sure we can find the crescent properly. That was very quick. Yeah, and I want to get a view of the crescent here to make sure. We're still doing the other one right now in here, so we're going to let that percolate for a little longer while I look at the crescent here. Let me try something just to get a quick view. There it is. Going to a... Nice. Okay. Alright, we're going to get that in here, so I'm going to move it. How about this way? All right, just a minute. All right, closing in. Closing in. There we go. It's called the Crescent Nebula because of this shape, as you'll see. And what I'll do is get a star and set it guiding on it. That's a perfect star. Can't get any better than that. Okay. All right. Let's go look at a location in space that you would never survive in for longer than, I guess, a fraction of a second. All right, this is a location where the temperatures are potentially several 100,000 degrees, unbelievably hot in these regions. And it's at a particular kind of star known as a Wolf-Rayet star. That's Wolf, W-O-L-F, Rayet, R-A-Y-E-T. And the Wolf-Rayet stars are stars that are so powerful that they've actually shorn their outer layers. Their outer layers have been blown off of the star by the extremely powerful stellar wind emanating from the core. And that core wind and temperature spewing out so much just pushes the whole outer part of the star away. And it's a very, oh, look at that. It's a very heavy star. I have to, I'm going to have to move it a little more. I got to get that in there too. And that part of the star then that's left is just literally the core. And that's this star right here, as we'll see in just a little bit. Okay, so I'm going to pull this up. Get back to our 1 second exposure. All right, and I'm going to move this down. What happened there? Come on, go up a little higher. Let's come out of there first, then go back. Oh, sorry. I didn't want to stack anymore for this. My mistake. That's what the problem was. Okay. All right. So now we gotta come get the rest of this, which is over there. So this has to come down here. We may not be able to see the whole thing, but we'll do it. Yeah, I have to stop that. Okay, so this comes down. Okay. Yeah, and that's gonna be tricky to get all of this in there. It's gonna be tricky to get it all in there, but we'll get it. This is really quite an object. Okay, we're gonna try that. Oh, come on, I didn't do that. Stop it. Just a minute. I'm gonna pull this back. We do get some delays. Oh, Isabella, you heading out? Thank you for coming. So good to see you. Everybody loves seeing you tonight, Izzy. Izzy? Sorry, I had a friend named Izzy. I apologize. Isabella. Okay. All right, we're gonna run with. Well, let's pull this out a little bit. See if this will work. Okay, that'll work. So now, let's go in and grab my stars now. All right, and let's pick the star. And that's a good star. Okay. All right, now back to this again. So now this time, in here, we're going to do we're going to go 30 seconds in here. There's some subtle details I want you to see. 30 seconds, off we go, and let's get out of here and go into the live stack. Okay, and we're going to dock it for now and fit to height. Okay, meanwhile, over in France, here is this image now, and this is the Measure 11 that we took earlier. Look at that. You see the star clouds in the Milky Way here. This is just beautiful. Okay, so now we're going to save this. This is perfect. It's beautiful. Okay. All right. And so that's saved. And now we can come out of here. Go back to our low light mode. And then head up to the same object here to show you the area around it in the constellation Cygnus. It's really something to see this. Actually, I will just tell it to go do it. Okay, my cord got in the way. It's not an emission nebula, it's a Wolf-Rayet. Okay, now we're going to go here. So now the other telescope over here is going to head up there. Oh, not yet it ain't. Why is that? Did I not do it? I must not have told it to. Yeah, correct, I didn't. Okay. All right, now, while it's going to the crescent over there, you'll see the crescent will probably show up right away, though, because this is an area that's really, really heavy-duty nebula. This is going to be beautiful. Let's actually get it in here. It's recentering it right now. It's going to center it right there. Okay, you can't see it, but it's right there. Okay, Now what we'll do is we come in here and we stop this. We grab our star. All right. And we tell it to give us a guide star. And go, go, go. Go, go, go. All right. So now it's going, and this will be a really good guide. All right. This one will be a 25-second shot. Off we go. And now over here on the other side, this is the object, but there is a few things we have to do to fix this. We got to color correct, and we also have to do this. We have to get the settings right. Look at that. Oh, look at that. Wow. That is incredible. That is incredible. Holy cow. Now, I have to say that, again, this is an extremely busy part of the Milky Way. All right. Very, very busy part of the Milky Way. So, when I show you this in a bit, you'll see that it's incredibly dense areas in here. Okay, so let's take a look now at this. You'll notice that this has this shape. Now, the star that's causing all of this is right here. That star right there has literally, as I said, pumped off its whole outer envelope. Now, how's a star built? I know, because I actually had to build a mathematical model of a star and have it work from the core all the way to the outer layers. And in a Wolf-Rayet star like this is what that star is. They have that, as I said, that very, very powerful stellar winds. And those stellar winds are so strong, as a matter of fact, that what they will do is push, again, that whole outer layer. Everything outside the core gets shoved away from the star. So the core is about 15 to 20% the size of the star. Right? So on our sun, the half a degree size object in the sky, there's only a fraction of that that's the actual core that's making all the heat you feel. All the rest is just along for the ride and not adding to the heat you feel. How about that? Okay, the core is pumping out millions of degrees, and the outer envelope is only 10,000 degrees in the outside edges. So when you consider that, this that all stars are like that, where they are kind of built the same way. So in that particular case, let me actually just make that full screen here. Oh yeah, look at that. So when you consider that that's how this works, what happens is that the core can remain behind, and the star can pump out all this extreme amount of energy, and as it does so, it can completely effectively dismantle the star, take it apart, and that's kind of what we're seeing. With these Wolf-Rayet stars. And so, but what's the ultimate fate of a Wolf-Rayet star? The ultimate fate is that it's going to explode in a massive supernova, because the stars are hugely massive, and this nebula is just effectively shy of a supernova, which is going to happen fairly soon. Now, let me show you another beautiful image. This is the wide field shot to show you the context of where this is sitting. Check this out. Look at that. Now we'll again pull that down. Look at that. So you see all this nebula here, and you see all this red nebula. This is diffuse nebula, and there is the Wolf-Rayet star complex. There is the star that blew off its outer layers, and it is absolutely the most inhospitable place in the universe. All right, it'll fry you. All right, now again, that is this, but this is that in a closer context. And if we do this, if I bring this up to near the top of that, then we'll actually start to see a darker background. You know, that's really something. That's just beautiful. And we don't go to the top, okay, because then we start losing data, but we stay just outside of it. All right, and so we end up with this amazing, beautiful object. Isn't that gorgeous? It's pretty, but it's deadly. Deadly beauty, right? And here it is again. Deadly beauty. The wide field. Again, all dark nebula in here, dark dust in here, punctuated by light areas of emission nebula. It's just incredibly interesting. Hey, Ronald finally showed up. Nice to see you. It's not cloudy. Look at these views. This is telescope 2. This is telescope 1. This one is the one that you donated. And this one is the one that we had out in the Sonoran Desert, which is now out here. We just have to, again, raise this one up higher because we can't see below certain latitudes, and we need to do that. So we're going to move the telescope up so that when it's sitting up in the air, it'll be close to the roof when it closes as well, because right now it's not. But that's beautiful. This is the narrow field, as you can see by the writing there, narrow field. And let's see, what are we looking at here? 18 exposures here. That's nice. I am going to have it tell us what this one is. It knows the Crescent Nebula. We're going to get it to line up perfectly. And then we're going to say that's the target object. Okay. And over here, we're going to, well, actually, we're going to say, we're going to save this as the Crescent Nebula object. And then we're going to come in here and save it. And then save the photo. So now you'll get to see it and take it down. And now it'll be on the skytourlive.org in just a few seconds. Let's now switch over to the other telescope and look at the wide field version of this same view. Here we go again. This is now that wide field version, and it is the Crescent Nebula right there. And we are going to set that target name and save it with image annotations as well. Okay, so there it is. And now we can now start saving this guy. Say save. We've got 17 shots taken here. Okay, there we are. Save exactly as seen. Look at that. Wow. Both telescopes pointing straight up in the air. Not bad. Look at that view. Look at that view. That is incredible. It's deadly within 10, 15 light years of this object. That's a deadly place to be. You don't want to be anywhere near this object in space. It's incredibly dangerous. So, wide field, narrow field, and all yours. Okay, so over here, I will actually say we've got 22 images stacked. Let's save again and save it exactly as seen. And then come on out of this. This was our last object tonight, guys. It is almost 2 a.m. here. And I really, really want to show you more. Ronald, I don't know what it would look like in the 8-inch telescope you have. I'm going to guess that it won't be nearly as impressive. Keep in mind, you should take a photo of it, though. He says he got ripped off on his first attempt to hire someone to do the slab. What do you mean? What are you talking about? Don't talk to me about that. We'll see what we can do. I have to have someone do the cement. I thought you had someone. What happened? JSCO, thank you, brother. All right. Now let's go back while that's just sitting there, and let's go back to this one. Look at that. Wow. I mean, you just can't stop looking at it. That's 22 shots. I'm going to save it and save exactly a scene. Wow. Look at that. Phew. Now, if we zoom in and just start moving around, you can see some of the details of the nebulous detail over here. And that's, again, what this telescope is good at. This telescope is good at showing you the wide expanse. And, of course, The Expanse was also a great show. Here's the dark nebula in here that you can see. This is what this telescope is good at. It's not good at zooming in and trying to do what the other telescope is good at, which is looking inside of here like this. Yes, that's reasonably good, but the detail in here is not nearly what we saw in the other one. But hey, it works, doesn't it? For wide field work, this is the way to do it. Okay, so we're going to save this. Save it again, exactly a scene with 25 captured and stacked. And there we go. Egads, that was such a night. Oh, man. Oh, that was a night, let me tell you. We rode up the Milky Way, and we came right down into Cygnus. You know what? I'm a liar. I gotta show you one more thing. I'm sorry. I have to do one more. Yep. That's me. What can I tell you? All right. I'm gonna come over here and do this. I'm gonna just do only this telescope, not the other one. And here we go. Didn't wanna, but I'm gonna. Man. Okay. Let's we're just gonna do just a quick shot. We're gonna do a 10-second shot here, just to see if I'm where I want to be, and I'll move it as necessary. I knew I should have just closed up and gone to bed. Oh yeah, that's darn it all. That's what I want to see. Okay, well, here we go. So let's go down here. Do that. Do this. Is it this one? And this one. Okay. Okay, this is the last object. All right. I think this is the last. No, this is the last object. Okay. Again, just a quick. I'll do 15 seconds because I wanted to show more here. This is not the exposure we're using. Okay, we're actually gonna do better than that. Okay, so this. Yep, that's the shot. Okay. Let me knock this off right here. Okay. Okay. It's the one I wanted to show you, so I'm gonna. All right. So this is gonna be a 35-second photo, and we are going to definitely use a longer exposure on this, because you have to see this. Darn it. I don't know why I'm doing it, but I got it. Okay, telescope one is parked, as you can see, but this is the one we're using now. So let's first of all do this. Let's come back here for a minute, and let's go here, and I want to move us up a little more. Just a little more. Ronald, you didn't, maybe you did, but you didn't tell me exactly what happened. Other way. Okay. Here we go. Okay. This will be the shot we want to look at. Okay, so now I'm going to close that. Yes, guiding stop. And now we're going to stop this. Take a picture. There'll be plenty of stars to choose from. Grab a star and go. All right, that's good. All right. It really shouldn't have a flat top. Yes, it's clear, Ronald. Beautifully clear. Okay, this is going to be a 35-second photo, not a 345-second photo. 35-second photo under guidance, and we're going to go into our live stack right now, and we're going to dock it up. We're going to dock it up, and that way, and then go show you the height only. All right, and that's important because we are going to show you what this looks like with the wide field, this region. You ready? You have 4 seconds until amazement. 2 seconds. 0. Boom. And wow. All right. This is a section of the it's called the Cygnus Wall. This is right here. This is one of the most beautiful locations in the night sky, right? It's part of the North American Nebula. It's sort of sitting on its side right here. And this is all dark nebula up in the foreground here with a nebula behind it. And there's so much more to this. But let's wait for the next exposure to come in to help sharpen up the curves. There we go. And now we color correct. And we're gonna want to reduce this a little right there. Okay, and now we're gonna ride this up just a little bit. Okay, would you look at that? Now this is literally one of the most unbelievable locations in the sky. It's part of the Cygnus Milky Way. And the Cygnus Milky Way has so much going on. We have a Mission Nebula here, everywhere, with dark dust in here. All right. Now, in the other telescope, in this telescope, when we actually use it, we can only see this part of it. Okay. We see all of it, but this is how much we see. It's only a small piece, but it is just gorgeous. All right. Oh, that's so beautiful. Wish I had this just a little higher, but this will do for now. Okay, so if we set our target here and give us a name for this, this is the North American Nebula. the part that we're in, and we're going to set that target name, NGC 7000, new general catalog 7000. Okay, we'll save the image with the annotations. Doesn't take much to get a good image here. This is 4. Okay, and it's there. So now we'll we can get out of here. And now let's see. Now sometimes I can overprocess using this to see what else is there, so I'll do that real quick. You can see there's a lot going on here. Pull that up and it's way more, but you can actually see the dark nebula very clearly and all the angry tentacles that it seems to have. Yeah, wow. Okay, isn't that something? And look at this beautiful area. See, with the other telescope, we need to do like a survey of this whole area so you can see it. Now here's what's to come. Okay, so of course you guys know that we're getting a third telescope here, and it's gonna be a 14-inch telescope, hyperstarred, so we get a wide field like this. We don't need to use the hyperstar; it can do both. All right, as could this telescope. But with a 14-inch, it would allow us to do a lot deeper examination of things. And so if we use the hyperstar, this is a 10-inch that's hyperstarred. In other words, making it a very fast photographic instrument with a camera on the front and so forth. Now, here's the thing. If we were to get that telescope in building 6, as we're going to do, then what we'd do after that is we would actually take this telescope, remove the hyperstar, go back to the native focal length, and this will be the telescope that we use our spectroscopic system on. And for that, we'll raise it up, and so it'll sit in the same spot, but the hyperstar will be on a 14-inch telescope, not a 10. And the difference is pretty amazing to go up 4 more inches. It's like getting much bigger eyes. It's just impressive. All right, 8 taken so far. Look at this image. Wow. All right, I'm gonna be honest. Seeing images like this make me want to immediately take a whole bunch more. But I can't stay up all night. I got things to do. It's beautiful though. This is the Cygnus Wall. This is a broad area where a lot of stellar energies are hitting, and where we're getting this emission of hydrogen, and we also have dark dust that's acting like a barrier to prevent it from pushing further in. You know, now there's some hot stars that are illuminating this and causing all this to happen, but none of them are visible in the North American Nebula. They're all hidden inside the black dark dust. All right, which is what's interesting about this nebula. Why don't we get rid of this for now, and let's fit the height in here. Look at that. So, what do you think? Isn't this amazing? Ronald says, did I see your images of the M31 with the sea star? Yeah, I did. I thought I responded. A sea star is a tiny lens compared to, the ones you could get. Like, you have a much bigger capability now. But the sea star is great. You can take it on trips and boom, have a great time. Yeah. Ronald, you don't have clouds and Benson, so don't worry. Yeah, so let me let's do one thing now. Let me drag this up the curve a little more. Let's get more contrast. Look at that. Wow. Oh, wow. I've missed this, guys. I've missed this part of the sky. I'm so happy that you are here with me tonight to see this. Thank you for joining me tonight. Now, see all these details in here? All those in here? Obviously we're not going to see. So the close-up view, and this close-up view with a little longer exposure and a little higher value. I mean, on the gain right now we're at 150 on this telescope. On the other one we're at a very high gain, and we don't want to use that kind of a high gain at all in reality. We want like 200 gain at the most. So that's cool. All right, so that said, if we could get a look at one of these little areas with this narrow field, you'd see so much more detail than here. And yet right here we see a lot of detail. This is incredible. Wow, you can see this tendril literally reaching over this section here. Illuminated, excited hydrogen gas. Unbelievable. Wow. How many do we have here? Why did it say my remote session is down? That's not right. Let's get the wide field back. All right, I got the wide field back. It's still here. So, we gotta go into the wide field system here and get it back. Okay. So we'll get that right back here. Here we are. Take no prisoners. Take no prisoners. Okay. Okay, there we go. So that's beautiful. A lot of detail in here. This is, you got to keep in mind, this is also straight up. We're looking through the least amount of air possible. So we're getting the most beautiful view of this, you know? Okay. This is incredible. All right. Well, let's dock the stack back up, and let's fit the height again. Beautiful. Look at that. Let's try something strange. I want to do this. Yeah. And then go here. Okay. Very good. And nice. Let's process this. It's gonna take it down more. Sometimes taking it down a level like this, it's dimmer, but you actually see better details in some of the ways. So we're gonna pull this up here. Here we are. Look at that beautiful knot of dark nebula. I wanted to show you that. Okay. So we're going to go to 20 and then turn it off. Well, save it. Wow. That's incredible. I believe it's Bob saying Mark is on TV shows in Canada almost every night. It's true, huh? There's a lot of people that watch these old reruns. No, I'm kidding. There's some good shows on up there, for sure. All right. Save exactly as seen. And we've done it. We have made a Milky Way tour. We beat the weather. And so now all I have to do is be able to park this scope and it'll be fine. As it is, we're safe because it'll actually, the roof will close even with it in this position. But I'm going to park it anyway because that's important to park it. So, wow, what a night. Okay, I'm accepting now for the park. And let's there it goes. You can see it moving down. See it moving into its park position. And that's it. We are golden. We had a really good night. This was phenomenal, guys. I want to thank you all for coming out and hanging out with us. I would very much like to register my thanks to those who donated. Thank you so much. That was very kind, unexpected, but thank you so much. We use that money to help pay for the Starlink, which brought you this stream tonight because there's no internet on the mountain right now. It's out. And so there is no one able to stream except for us up there. I offered the Starlink to the other astronomers on the mountain, and we're still working that out. But there was an infrastructure failure, and so the other buildings are out right now, unfortunately. So hopefully they'll take my offer because I want them to have internet, and this is right now the only game in town, and it's really good. And with a Wi-Fi extender or a couple of them down the line there, everybody can use this one Starlink antenna. I'm happy to offer it to them. All right, so in any case, wait a minute, what? Kathy Missick says, thank you, Mark. I missed the stream. What do you mean you missed the stream? You were one of the first ones here. What'd you do? Hey, Robert Miller. Kathy, how'd you miss the stream? Okay. Well, it doesn't matter. In any case, guys, I hope you have a good evening. And I'll talk to you next time. I'm going to set up a plan for viewing other objects in the Milky Way as well. And I will be out in Benson in September when I will raise this telescope up and maybe be installing the 14. It depends on how soon the 14 arrives. We have to have it crated and shipped. Here's one of the things that I do need help with, if some of you know a way. I need a shipper that can also go to someone's location and pack in boxes or crates the telescope to get it out to Mesa, where we then drive it down to Tucson and then out to Benson. If any of you know any shippers or craters, people that will crate and freight for us, please let me know. You can hit me down there. Hit me up at contactskytour@gmail.com. All right, because that's something that's going to be very important. So we will need, contactskytour@gmail.com. If you have any ideas for us to do that, I haven't started looking for craters and freighters. There's actually a company called Craters and Freighters, but they're here in Connecticut. They need to be in Maryland and able to crate it up and ship it. We can ship it by a freight company. That's not a problem, but getting it crated up properly so that it reaches Mesa without damage is very important to us, obviously. So if any of you know anyone who can do that, or anyone's in the shipping industry that can help us out, man alive, that would get you some perks with us, I can tell you that. Anyway, you guys have a good night. And if you need to contact me about any of that, it's contactskytour@gmail.com, or through my Facebook site, obviously, or through skytourlive.org, the contact form. Either way, I had a great time. Look for the photos. They'll be up. They're already up there on the site right now anyway. So you guys have a good night, and we will talk soon. This has been great. Good night, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.